Okay, here we go. Week 6, day 2. We are going to continue solving rational equations. We are going to continue with our solving rational equations from day 1. So basically everything that we learned day 1 is going to come in handy today. We're just going to kind of up the game a little bit. So my reminder here at the beginning is remember that if we have something like x over x plus 4 equals 9 over x plus 4, because the denominators are equal, that means the numerators will equal, okay? So denominators have to be the same on each side of the equal sign for those numerators to be equal. Alright, here's the first equation we're going to do. So just the same as when we were adding, subtracting fractions, like our rationals, we wanted those denominators to be the same. Again, it's going to be the same type of concept here when we want our equations, both sides, to equal. Okay, so on the left side of my equal sign, I have the quantity x minus 1. On the right side, I have just a 2. So with that same concept with adding and subtracting, where we were asking ourselves, what does one have that the other one needs? We're going to do that same thing here. Okay, so what does the left fraction, x over x minus 1, have that the right fraction, 1 over 2, needs? Well, for the denominator, it needs that quantity x minus 1. Okay, what does the right fraction, 1 over 2, have that the left fraction needs? Well, they have the 2 on there, okay? So I'm going to multiply by 2 over 2. Okay, again, okay, when I multiply these, so 2 times x on the left, okay, 2x. The denominators, don't waste your time multiplying them out, okay? Leave it as 2 times x minus 1. Do not take the time to multiply denominators, okay? Equals. On the right side, normally I would have to distribute, but since it's just a 1, okay, I have an x minus 1 over 2 times x minus 1. Remember, our goal was we wanted the denominators on the equal sides, both sides, to be equal, okay? Hey, right here, what can x not be? Okay, well, x cannot equal 1, okay, because I have this x minus 1 on both sides actually now, okay? So, if my denominators are the same, well, if the denominators are the same, that means my numerators can be equal. Okay, so 2x equals x minus 1. Well, if I solve this equation, subtract x, so x equals negative 1. Okay, again, we wrote this what x cannot be right here so that we had a fast way to check ourselves. Did we get a positive 1 as our x? Nope, we got a negative 1. So that means x equals negative 1 will work. If you were to check your answer up there at the top and plug it back in, it will indeed make those equal. Okay, next question. 2 divided by x plus 1 equals 1 over x minus 2. I want you to pause and I want you to write down what form of 1 you would multiply on both sides. Okay, so what does one have that the other one doesn't have if I were going to try to get these a common denominator? Well, on the left it had the x plus 1, the right needed the x plus 1. On the right hand side it had the x minus 2, the left side needed the x minus 2. Okay, remember, do not waste your time multiplying these denominators out. X minus 2 times x plus 1. Okay, on the other side, I have x minus 2 and x plus 1 on my denominator. Don't waste your time. The denominator does not matter multiplying it out. Okay, what does matter is that your numerators you are going to want to multiply. Okay, so that 2 is going to distribute. 2x minus 4. This 1, again, is going to distribute to x plus 1. Okay, hey, I'm going to stop here. Write down what x cannot be. Okay, so there's your values of what x cannot equal. Hopefully yours were the same. Okay, I took that denominator and set them equal to 0. Hey, my denominators are the same on the left and the right of my equation, so that means my numerators are going to equal. And I have an equation that I can solve here. And here at the end, I wrote down what x cannot be for a reason. I'm going to check, hey, is that in my what x cannot equal numbers? And nope, 5 is definitely not one of those numbers, so 5 is our solution. Again, if you were to put this in the original problem, it will make those sides equal. I'm going to let you try this one on your own here. So here we have x minus 2 over x plus 4 equals x plus 1 over x plus 10. I'm going to let you get it to the point where you are ready to set the numerators equal on your own. I will pause and play so you can check some steps. There is your form of 1, okay, on the left and the right. Hey, I'm going to give you one little hint here that you want to make sure that when you're multiplying your numerators together that you're distributing, okay, you will end up with a trinomial on each side after you distribute. So go ahead and multiply those numerators and see what you get out. Alright, after you distribute those numerators, combine your like terms, there's what you should have. Next, what can x not be? Alright, so I did write what x cannot be over there, and because my denominators were equal, I went ahead and set the numerators equal. I want you to solve this equation and find what x is. Alright, there is the value that I get for x after I solve that equation. So x equals 8. Is x equals 8 one of these cannot be numbers? Well, no, it's not. Okay, so that means x equals 8 is our solution. Okay, here we go. So on a problem like this, I have more than one term on the left, and then I have one term that's on the right. If I look at just the left side first, you might notice that, hey, here on the left, they already have a like denominator. Hey, you know what that means? Combine those things together. We know that two fractions with a common denominator means that I can add them together, so go ahead and add them together. 2x minus 8 divided by 2x plus 2, and now I'm going to throw in the right side of my equation here. Equals 2x minus 3 divided by x plus 1. Okay, there are a couple of different ways to go about this question right here. I have 2x minus 8 on the left over the 2x plus 2, and I have the 2x minus 3 on the right hand side over the x plus 1. Remember our goal here is one way to look at it. You could say, hey, I need my denominators to be the same. So I could look at it this way and say, hey, I've got 2 times x plus 1 on my denominator. I don't care about my numerator right now because I'm going to have to multiply that out anyways here in a minute maybe. So I just care about getting my denominators the same. And this just has the x plus 1. So if you look at it this way, you could say, hey, on the right hand side I just need a 2 over 2 to make it the same. So that now I have 2x minus 8 over 2 times x plus 1. Now, some people may have done this question differently, so if you started this question on your own and you went, hey, I actually could do this different, I'm going to show you something here in a minute. So if you are thinking of a different method, don't get too far ahead of me here. Right here, if I say, hey, what can x not equal? X cannot equal negative 1. Go ahead and stop and solve the question. Alright, I solved right here and I got x equals negative 1. Hey, x equals negative 1. Uh-oh, that's my no-no. X cannot equal number. So x cannot actually equal negative 1. So I'm going to stop right here and say no solution. Alright. Now I'm going to go back up to this step right here. And I'm going to talk about how it could have been done differently. Okay. At that step right there, you could have done this instead if you wanted to. You could have, so there's my little arrow here going on. You could have factored the numerator if you wanted at the same time as factoring the denominator. And you could have done this. You could have said, hey, I actually can get rid of those 2's right there. Will that help me doing that? Yes, it would, because my denominators then would be the same. All that's going to change is now I have this equation to solve instead of what I had down here. So I would do this. And I'm still going to get that same x equals negative 1, which can't work, and that same no solution. Okay, so just showing you that there is more than one way to solve that equation. that is all I have for you today, everybody. So if you have any questions, remember, hop onto those tutoring sessions. Or make sure that you attend the live sessions during your block. Have a great rest of your week.